Okay, we are back again for Advent of Code 2022. Today is day 7. I think I found a setting on YouTube to make it so that I don't have to click to start the broadcast at the end of the delay. So I'm gonna test that out today. Hopefully when this hits about a minute, the stream actually starts. Otherwise, I need to go click in. But yeah, we're doing pretty well. I'm quite pleased. We are above the fold here, sitting at exactly top 25 after 6 days, so that feels good. In a few of the previous days I was remarking, wow, I wonder when the problems will get hard, and someone actually did an analysis on all the past puzzles from different years and their average solve times. The black borders here are the weekend days, which generally have the harder problems. And if you look here, this is day 7. We see a noticeable jump in difficulty. I mean, 2021 was an exception, but in the other days, this is kind of when the problems got hard. So if not today, probably tomorrow or the next day, there'll be something a little non-trivial to do. Just given this pattern, I might even crank up the delay to like 5 minutes or so starting at when things get harder, just to try to make it so that the stream is still delayed enough that the solution won't be out before the leaderboard closes. But something else to worry about in the future. Other than that, not much to say. Actually though, I am very surprised that GPT-3 wasn't able to solve the problem from yesterday, because I know someone in one of the Discord servers that I'm in tried feeding this in and got a valid answer. The code that the chatbot produced was correct, but we didn't see any bot-looking submissions on the leaderboard. I believe that this is a legitimate solution, and not a bot. I think I was just a competitive programmer who read the problem really quickly and wrote the answer and didn't check against test cases and just submitted. So, yep, we will see how today goes. Hoping for some sort of a graph question, because surely one will have to come at some point, and it seems fitting with day 7 being a bit of a spike in difficulty that this be the day when, you know, something a bit non-trivial is introduced. All the previous problems have sort of been, oh, just confirmed that the stream did in fact start, so I'm very happy about that. But yeah, since the other than parsing being tricky, logically, most of the previous days have been... Oh, I have to start this. Make sure I have everything open, instead of just blabbering. Yeah, it's been the parsing that's tricky, right? So, let's see what actually happens here. Oh, yeah, it is difficult. What is going on? HJPF. determine the total size of each directory? Is the sum directly total size? Is it just all the files? Can this be inferred? cd, if you ls means the current directory contains a file, means the current directory. Okay, I see. So these are the file sizes, so we have to reconstruct a graph. Oh boy, well, this is an interesting one for sure. What am I doing? I don't know if this is actually good or not. I don't think we need to do that. I don't know if there's a, maybe there's a fast way to do part 1, but I think we're definitely going to need to do some sort of parsing to do this. Probably want to do it this way. I think this work. So we always just start at the root. Oh, I'm just gonna ignore the first command. So directory is gonna be this. If we're doing this, we actually go up. Else we're gonna be pushing inwards. I guess this doesn't work. Maybe it does work, who knows. So that's our current thing. Else we're gonna push in, so I guess so we have this, or we also have LS's. So we're gonna have to read a bunch of lines. I guess every ls, so it's either starts with a number. Okay. That's the file size, and then the name should be Oh, I mean we have to read the next things in the line. I guess we would do a full parsing of the input first. I'm just curious if there was a fast way to just proxy. Oh. Okay. Is it just like a DFS or something? Would that work? We know that this is in here. We know this is in the directory. We can push in. We know that that's the size of there. We know that those things are inside, and then this is inside. We push in. We pop back. We accumulate these things. Yeah, okay. Okay. Maybe we'll do it this way. So if we see one of these, if we see an LS, we need to so if it's a directory, it's nothing. So it's just gonna be so either it has to be this, then the new node of right? Oh, I guess it doesn't matter. We can doesn't matter what the directory is, because I think this doesn't matter. Oh, this is pretty inefficient. It's gonna be file size, name equals parts, like this. And then current.children.append new node of name, and the size is the file size. otherwise we're gonna push into new directories, so we know we're cding into the directory, so cur.com. A new node of name D, and current is the node. Something like this. I think we just skip. Who knows? Oh, of course. Wait, where did I write that code? Oh. Will this work? Okay. Oh, whoops. Wait, is that not it? Hello? So then what was the question here? If this group less than 100,000? Should be like that. Oh, we are so slow today. Total, to run this you will need to find a directory you can delete that will free up enough space. Total size of the outermost directory is that. This means that so the total size of the outermost directory is this, so unused is this. Okay. So pretty sure this gives us the possibilities, right? And then we just need to figure out the differential. So we have unused is going to be equal to available, I guess, minus the slash directory, and then dot values. If so, we need this plus x to be greater than need. It's going to be x. Okay. So do that. Let's just set that. Think it's okay. Pretty slow day. Oh dear. Okay. Now we will undo the delay and come back and explain. Okay, I think we should be live again. I'm just waiting to see that on my other screen the stream is live again. But yeah, I should have known what I was getting myself into when I asked for a graph question. This was indeed a graph question, and day 7 was indeed a non-trivial thing. We'll just take a look at the leaderboard real quick. Betaveros coming in with a really quick solution, which is interesting because he's using his own custom programming language this year. But yeah, 15 minutes for the leaderboard to close today. Definitely a trickier question. I struggled a bit trying to think if there was an intermediary way to solve this problem, but there wasn't, and so we just threw something together. I didn't really get a chance to clean anything up, so I think we'll just walk through the problem together and try to explain what was happening. So the question, day 7, is called No Space Left on Device, and the problem input for today was basically this. And so if you're familiar with like a terminal, right? It basically was simulating you messing around on a file system. And so there are a few things that could happen. You could say ls, which would give you basically a listing of things in the current directory. And things are either another directory or a file. And if it's a file, you're given how big the file how big the file is and the name of the file. Another thing you can do is change directories. So there's two versions of change directory, right? You can either go in a directory. So this is saying I'm going to drill down to the A directory and now that I'm in a different directory, if I ls, these are all the files in A plus another folder called E. And if we go into E again and we list it, we see that there's one file I. You can also cd ... which of course brings you up a directory. So it's like we were drilling down lower into the file system, and now we're coming back up. And so the question is asking, we want to determine how big in total each directory is. And then the actual question that we want to answer is find all the directories whose size is 100,000 or less, and calculate the sum of the sizes of all of those directories, right? Note that we never, in these command outputs, are given the size of directories, right? It just says this is a directory. So in order to compute how big a directory is, it's going to be, of course, the sum of all the files in that directory, but not just the sum of the files in that directory, but also the directories below it. There probably is a much cleaner way of doing this. I don't think we need to necessarily even iterate through. We could probably just accumulate the yeah, I wonder. Maybe this will end up being a cleaner solution. Sorry, I was just thinking, but we could try this out as we code up the solution. So yeah, we basically need to be able to take this terminal output and parse it into a structure where we can ask questions not just, oh, how big is file F, because that doesn't help us. What we actually want to know is how big is directory E and how big is directory A. And we need a way to reverse engineer that. And so I guess the key intuition here, which I kind of coded up a bit too slowly today, is this is very similar to a depth-first search through the directory structure. You can assume that, maybe this wasn't a safe assumption to make, but all this is doing, you like pushing into the like various directory structures and popping out and listing a bunch of stuff, is doing a DFS if you imagine this virtual file system as a graph. And just given that advent of code inputs are generally pretty nice, you can assume that we're not, or I made the assumption at least, that you're never going to see like, spamming ls in the same directory, or recalling ls from a directory that we've already seen before. So because of that, we can parse this output and basically build up the graph. Build up the file system graph, and then it's pretty easy after the fact to go ask questions about the graph. So how does this work? I'm going to remove some of the stuff that was pointless. Originally, I was trying to do something where I was only looking at the things at the commands, like the commands and not the outputs, and handling those separately. But it turns out it's probably just as easy to handle everything in line, because again, assuming the input is quite nice. And so what does that look like? Well, I guess I would probably want to rename this node thing. Node's just like a generic thing for a graph algorithm, but this is actually probably a file in the file system, right? So maybe it makes sense to just rename all of the times we make a node to file. So there's a node. there's a node. I think the rest we can deal with later. If I just run this, oh, node is not defined. Files equals file. Right, so for file, we're given a name. I don't really even think we need to know the name of the file. It's just useful for debugging purposes so that when we can print stuff out after the fact, we know what we're looking at. A file could also have a size, right? In the case of this, like this file has a size. And in the case that it's a directory, it also has a bunch of children files in it, right? It could either have more files, so this is a recursive data structure, right? A file, kind of like in Unix land, could also be a directory. So a file, if it's acting as a directory, could have more children files underneath it. And we also have this useful thing, parent. We're using parent to store a pointer back to, I guess, like where we came from, so that when we see a cd ... we can jump back to the file that we were looking at before we cd'd into the current directory. And this is useful because I guess much like, oh, we could probably even, it might even make sense to rename our variables this way too, right? We are always operating in a single directory. So for example, here we start in the root, and when we call ls, we're getting all these files, and we know that we're the root. This is the current file we're looking at, right? This file object should be referencing the root. Once we cd into directory A, now our like working directory is actually A. So anything we're doing where we're adding children or, you know, computing the size and stuff should be operating on A rather than the root. But at the very end here, once we cd back up, we might go back to the root. And so if we don't store the parent pointer, we have no way to know where do we go back up to. So that's the purpose of that. So we define a class that is a file, a very rough version of a file. And so it turns out we didn't need to do this default dict stuff. We're just using this recursive data structure. And we store a pointer to the current directory we're looking at, the working directory. And then we just go through and parse this output. We parse the input. And so if the line starts with the $, we're running a command. So the command is either going to be cd or ls. If the command is cd, we want to look at where we're going. So directory. Unfortunately, dir is a reserved name in Python, and I don't want to overwrite it. So we want to look at what directory we're going to. So if the directory is ... that means we're pushing up, right? In other words, we want to go to the parent of the current directory we're looking in. So our working directory should be where we're working, their parent. So simple enough, we're going upwards. Otherwise, we are cding into another new directory. Now, this is where we kind of use the assumption that the input is going to be nice and that we haven't seen this directory before, or we haven't you know, done anything with it. So we create a new file, and the new file name has the name of a directory. And I don't think I ever really used, oh, I did, I guess. Yeah, so we want to create a new file, or a new directory, I guess. We will call it directory. We also have to do some important stuff here. We want to set the parent pointer to where we currently are. This is essential for doing this DFS because it lets us go back later on. If we don't set the parent, we have no way to get back to where we were after we've done exploring this directory, right? So we set the parent pointer. We also, wherever we are currently, we want to add this new file as one of the children of the current directory. If you can imagine the tree-like structure of the file system, this now becomes a new child of where we currently are. And then finally, we update the working directory to this new file. So officially at this point, we've like moved into this new directory because we've CD'd into it. Anything we do after this fact is going to be working on that directory. I ignore the PC stuff. This is a vestige of when I was trying to do weird stuff with only looking at the things that are dollar signs. So if we see a ls command, it doesn't even matter. We don't actually do anything useful with that information. All that tells us is that after the ls, we're going to be seeing either files and their sizes or directories. And because those are the only things other than these commands, we kind of just treat it, we handle them in the else branch. So else, the current line is telling us something about either a file and its size or a new directory. So we get either the size and the name, right? Is going to be line.split here. And so if the size is equal to the name of a directory, I kind of made the guess that we can just skip this line as well because, for example, this is just telling us there's this folder called E, which is great, but it doesn't really mean anything. We're going to be looking into that directory later anyways, and that's when we create, the new file object, the recursive data structure, and we go into it. So we don't have to do anything actually in this case. So all we care about if size is not equal to dir, because this means only care if we are looking at a file. So in the case that we're looking at a file, we can turn the size into an int because that's really important to do. And all we have to do is the current directory we're looking at, we add another child to it. It's a new file, and the name is name, and the size is size. Maybe we'll do it this way. Great. So now if we now at this point, we've kind of built up we should have built up the entire graph. So if I do this, I guess it doesn't really help this way. I think we have to do, it doesn't really help unless we actually do the DFS, right? So just assume at this point we've built up kind of the structure of the graph, of the file system. I think it should all be relatively reasonable. And so now, I guess, let's solve part one first. So what does part one actually say? Now we have to go through and figure out which directories are less than, I guess, what would it be? Like 100 kilobytes. And sum those all up. So I guess simple enough task. We want to, part one is going to be 0. And so we want to define a depth first search, and we can start it, and the DFS will let us we want the invariant to return the size of node of the given file, right? So we'll call this file, right? So if the file has no children, that means it's just one of these files that we created. So simple enough, the size is how big the file is. Because it's a DFS, we also, I guess we don't need to even keep track of scene probably, because we're not going to get stuck in a loop here. We can assume it's a tree. So that actually simplifies things too. I'm pretty sure we can just remove this. So let's see. Oh yeah, that actually does simplify a lot. Okay, we do want to keep this so. So otherwise, we're looking at a directory and it has a bunch of things beneath it. And so we want to keep track. We have to, in order to answer, for example, how big directory A is, we want to ask how big is each of its children. So these ones are easy. We know their sizes. We can just grab them immediately. But we do need to know how big E is, and in order to figure out how big E is, we need to figure out, we have to loop over all of its children. And so that's why this becomes a recursive problem, right? So we want to loop over all the children in the current directory and basically add the size that DFS returns in there. And we trust the recursion to give us the correct result. Then this was just kind of more of a convenience type thing, and it actually helps with part 2. I guess we can define something called directory sizes, and we want to set, or I'll just call it sizes, right? While we're doing the DFS, we might as well store, because after we've looped through all the children, we know how big the current directory is. So we can just say, this file, how big is it? Well, it's total size big. And then we want to return total size, right? And so now if we DFS, and you have to pass it something to start, a starting node. And so the start of the file system is the root, and we keep, I guess, a pointer to that. And we initialize the DFS to it. We don't need this stuff. So perform DFS to seed the sizes, to seed sizes, right? And now we want to answer part 1. So if we print out sizes here and make sure we have this example copied, and we run that. Ignore this, it won't work yet because I changed a bunch of variable names. But yeah, we see here directory E is 584 big, directory A is this big, D is this big, and the root in total is this big. So that's exactly what we're expecting. And so we want to figure out the sum of the total sizes of directories smaller than 100,000. Now with this sizes dictionary, it's simple enough. It's just part 1, what is the answer? It should be the sum of all S in sizes if S is less than or equal to 100,000, right? And close bracket. If we run that, sum of S for does this not work? Oh, S for S in this. There we go. I think I accidentally clicked something and it copied. This is the downside of using the clipboard as input. Great. So in this case, we get 95437, which fits the sample. And if we run it on the real input, we get over here 109. Wait, this number? Oh, this actually isn't right, huh? Interesting. Find all the directories with the total size. The interesting part is that when I was able to solve the problem, I wonder, what happens when we run this on here? We got a lot of things. Are any of them like exactly 100,000? I doubt it. Huh. I'm gonna come back to that because I think figuring out part 2 and just removing that ugly output will kind of help us out a little. So part 2 basically asks our total file system, so it has, what is this? It'd be 123, like 70 megabytes of space, I guess. And to do this update, we need this much space. And we need to figure out the smallest directory we can delete to free up enough space for the update. So it's basically a two-step process. We have to figure out how big our directories are in total, right? And then figure out what we need to delete to free up that much space. Well, that's simple enough, because when we printed out the list of sizes, we knew exactly how big the root directory was. So that is given by unused is going to be this amount. It's going to be how much is available minus how big the used part of the file system is. I guess just to be really explicit about it, used is this, and it's going to be this, right? And what we want to do is compute the smallest directory to delete in order to free up that much space. And so we want to iterate through all of the directories file sizes, and we can sort that array so we go from smallest to biggest to make sure we see the smallest possible one first. And if unused, we can just call this size plus the size is greater or equal to how much space we need, then we found the answer, right? We found a directory where if we add it to how much space is unused and we exceed or equal to how much space we need, we can install the update. So we can just say part 2, the answer is going to be size, and we break out so we don't loop infinitely. Let me just refresh this. So yeah, we get the correct answer for part 2 here. I'm curious why part 1 is not giving the correct answer though now. That is a weird curiosity. We don't need this anymore. That was from before. I'm very curious, because I don't think it's like a inequality thing like this. No. Live debugging. We're going to be seeing a lot more of this as we go later into the year. If I run it on the sample here, we do get the correct answer. The sum of the total sizes of those directories, huh? Oh, whoops. Oh wait, no, that should be fine. I thought I was using the wrong inequality, but that wouldn't have made sense. We want to do the DFS like this. Yeah, that seems totally reasonable. And we're passing in the sizes of things. That seems fine too. Very weird. Did I just write the wrong number? Copying. Like, this should be equivalent, and I'm pretty sure. So the interesting part is I could probably just go back in my video and see what code I wrote there. Total size is this for each child and the current child. We want to iterate over the child, so the recursion seems fine here. Sizes file.name is equal to total size. Yeah, this seems totally reasonable. Huh. Well, I'm gonna stare at this for like half a minute more, and if I can't think about why I'm getting the wrong answer, I will probably just figure it out offline and talk about it tomorrow, because I'm done thinking about this problem. Okay, the number is smaller than, wait, 1, 2, 3, 4, 5, 6. Yeah, this number is smaller than it should be. We're like excluding some directories for some reason. File.size, yep, that seems fine. We append it to the children. Maybe just for clarity, I feel like this reads a bit better. Boom, 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 boom. I mean, this isn't the problem, but Don't think it's on my inputs being truncated or something. No. Huh. Very strange. I'll have to go back and figure out what I was actually doing. Find all the directories with a total size of at most 100,000. Just out of curiosity. In sizes. Boop. No. I want to sort on the size of the values. Like, how many things are this big? And the real question is, are these all directories? PGP, VCP. Yeah. Oh yeah, I guess they're directories because they don't have like a fake extension on them. So things that are smaller than 100,000 should be all of these guys. I wonder why we're off. We want 158. We don't even hit that. 158. What is going on? Should I be suspicious that these two directories have the exact same size? Oh, I wonder. Maybe it was important that I'm just curious, because this is the only thing that was different, I feel. Other than the way I was doing my parsing. File.name in scene. Print duplicate. Otherwise scene.add file.name. I doubt. Oh, look at that. We do see duplicate files. Why is that the case? So in that case, we just want to return file.size, or maybe we even return 0. Scene.add file.name. Actually, I'm curious about this. What are the duplicates that we see? In doing the... I mean, we shouldn't see a duplicate, right? For DFS, file.name, or scene.add file.name. Okay, we can stop printing this stuff out, because I already know. Oh, of course. Okay, no, it makes sense now. when we run, I guess if we run ls, we'll have seen a lot of the times uh, the directory printed out many times, the directory name, but we only ever cd into it once. But as a result of I guess how I've structured parsing this input, I make a bunch of these duplicate folders, and we don't want to incorporate them again into your DFS because we'd be like double or triple or quadruple counting all these directories over and over again. So there's two ways we can deal with it. We can deal with it in the DFS, which I think is probably the way we would want to do it, because I guess what happened is like, now I'm curious. Okay, I thought I was done with this problem, but we're not. What do we see a lot of? We see a lot of this tr and v blah 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 blah. So let's search for how many times this comes up in the problem input. Make it a bit bigger. So we do an ls and we see it in here. We cd into here. Oh, we see another directory called this, huh? Is it not like a perfect tree? We're lsing and we see another directory called this. Am I misunderstanding the input? Whoops. Let's make this a bit bigger. It's not like it's representing like a duplicate, like that there's a folder that doesn't make a perfect tree. I'm confused why that's the case. But regardless, we can just make it so that if we have seen a directory name already, we just don't do this iteration over and trying to sum its constituent stuff. And we just like say, okay, we're done with it. So let's do that. Let's do some of this and try running this, and we're getting zeros for some reason. Oh, I probably have to do this at the end. Like that. Now we're getting very wrong answers. What? Oh wait, are we? What is going on? Do 584. These numbers seem accurate. And oh, we got 954 here, yeah, and then this was 249. Oh, I was just not reading the samples correctly. Okay, and then if we run this, but this is definitely wrong. What is going on here? Somehow I broke stuff more while trying to go through and code stuff slowly, which is a curiosity. Are we just supposed to return 0 here? No. I am very confused. This is definitely... It's the right answer for part 2, but not the right answer for part 1. But we get the right answer for part 2 and the wrong answer for part 1. And if we put this stuff back, we get, oh, also the wrong answer for part 1. I don't know. I'm gonna have to look at this offline, but I think I have made this video way too long already. But yeah, not such a great day. Hopefully we'll be doing better tomorrow, but thanks for watching.